So this is kind of an age-old problem. The traditional way by which we take medicine is most often an oral route. And there's actually a vanishingly small quantity of the medicine that gets to where it needs to be, right? This is really the source of a lot of the side effects, right? And the challenges in modern medicine. So the invention is an adaptation of a very common analytical tool known as the enzyme-linked immunosorbent assay, or ELISA. This is a tool that's used in research labs, it's used in clinical settings, it's used in industrial settings, and really its purpose is to be able to detect and quantify the presence of a specific molecule. What our invention has done is we've found a way to decrease the runtime of that assay. So now instead of 7 hours, the assay is done in about 30 minutes. And that's enabled by the fact that we can now create the assay in a dry state. So we can pack most of the components of the assay together into a biomaterial system. And so because we've been able to make it dry, we can make it more stable, making them more available, increasing their shelf life, so decreasing their burn rate, the rate at which they're thrown away, which is a surprisingly high turnover rate per year and comes at a significant manufacturing cost. So that cost trickles down to the healthcare system and ultimately to the patients that rely on these medicines. At the core of the invention is a molecule that is an agricultural product. It's actually derived from the kernels of sweet corn. One of the things that's enabling about being here at UF is that we have a sweet corn breeding program that is unique within the country. So we have access to plant varieties that no one has ever seen before. And the variety of plant influences the characteristics of the molecule that we use in our invention. But it really is the product of being at a place like the University of Florida, right? And if it wasn't for the other resources and facilities that we have access to, we really wouldn't have been able to make the progress that we've made so far. As someone who, philosophically wants to make things that do things, inventions, right? You're making something that does something. And so to be recognized for our contribution in this space from UF Innovate is really it's a remarkable feeling. So the folks that I'd like to thank, of course, because I don't do this in a vacuum, include the students and the scientists who've been involved, the College of Engineering, the Department of Biomedical Engineering, all our collaborators at UF who are really helping us see a path forward and working with us to see if we can improve the actives that they are developing. So can we have a joint effort that will really drive medicine forward? The grand vision here is that, a molecule from a crop that is, one of the most consumed vegetables in the US, a really important crop in the context of Florida agriculture, but a crop that hasn't really been the source of a commodity chemical in the past may now be revolutionizing modern medicine.
Marcio Resendi and Greg Hudalla have developed the one-shot ELISA test. The ELISA test is done in laboratories around the world and requires multiple steps. This innovative technology allows for the test to be done in fewer steps and will enable access to this test to laboratories and places around the world where there isn't specialized equipment. So congratulations, Marcio and Greg.